You're able to point.
All right, we will go ahead and get started. Good morning, and thank you all for joining. I'd like to welcome everyone to our last session of the 2024 Watershed Wednesdays series. I'm Emily Dekar, the Agricultural Coordinator for the Upper Susquehanna Coalition. Watershed Wednesdays are hosted by the Upper Susquehanna Coalition and the Otsego County Conservation Association. All of the sessions from 2024, as well as past year's recordings, can be found on the USC website, as well as the Facebook page. To get things started today, our presenters are Brandon Ashmatat and Jake Lynch from the Cortland County Soil and Water Conservation District. Brandon is a graduate of Paul Smith College with a bachelor's in fisheries and wildlife science and a minor in forestry. And Jake has a bachelor's degree in environmental studies from Alfred University and master's of science in recreation management from SUNY Cortland. Both of them have been at the Cortland County Soil and Water Conservation District since spring of 2024. They're going to give you an overview of assessing road crossings in the Upper Tioughnioga River watershed. We will hold questions till the end, and then once they are done presenting, we will open it up for questions. Anybody can either raise their hand or put questions in the chat. Otherwise, I will turn it over to you guys.
Awesome. Thank you, Emily.
Thank you, Emily. Yeah, very nice introduction. That picture of us, I'm holding a trout from the Otsego River, actually, and Brandon's got a black duck mallard hybrid that was probably around the Tioughnioga, which is what we're going to be talking about today. Right into it. Brief overview of what we're going to be talking about. So there was about 250 culverts that were identified by this entity called NAACC, the North Atlantic Aquatic Connectivity Collaborative. And NAACC has a aquatic connectivity assessment that we do on stream crossings on roads, and culvert assessments, which is a separate thing. So every culvert or crossing, I should say, gets a culvert assessment and a NAACC assessment. And then we have a ranking system that we will explain throughout the slide show. And then towns is who we help, and we'll explain all this as we go. The watershed we're focusing on is the Upper Tioughnioga Watershed. It's about 764 square miles, and roughly 290 square miles of that is within Cortland County, which is most of it. And you can kind of see it on that map there. It's the blue outline is probably 90% of it is within Cortland County.
So we're moving. What is NAACC? So it's the North Atlantic Aquatic Connectivity Collaborative. It's a network of individuals, university, conservation organizations, state, federal natural resources, transportation departments, and they focus on improving aquatic connectivity across 13 state region, basically the whole Northeast. And it's a collaborative effort to address criteria with stream crossings, such as the ecological concerns, transportation infrastructure, and public safety. So why focus on transportation networks, streams, and river systems? Well, they're all linear systems in the landscape. So they cover the whole watershed and they intersect at many points. So they're pretty easily accessible, and NAACC goes through and identifies these crossings using maps and computer systems. So main functions are transporting materials and organisms. Both roads and streams obviously are used for passage of organisms. And to achieve this, connectivity is key. Where these linear systems intersect can cause habitat fragmentation and disrupt aquatic passability. To achieve the goal of connectivity, we need to inventory and address barriers to movement and stream continuity, as well as hopefully addressing and helping towns and other transportation systems address problems with infrastructure, which will benefit public safety. So there's three main NAACC assessments. There's aquatic connectivity tidal assessment, obviously, which addresses tidal systems. Non-tidal assessment is for non-tidal areas. And the terrestrial connectivity assessment is an assessment of crossing specifically made to allow terrestrial organisms to pass underneath roads. We think there's one up in Labrador on 91 that allows salamander movement. That was helped put in by DOT and DEC, but we didn't focus on that one. That wasn't one of the ones that was given to us by NAACC. So throughout the process, we had to get training on the NAACC protocols. It's a uniform across the whole region, so that way it's consistent data. After completing an online training through UMass, I believe,
Yep.
and we had to complete 20 supervised assessments by a lead observer. Basically, they had already gone through this training, and then they go through it with you. After you do your 20 assessments, they're reviewed by an L1 coordinator, and quality of data collection is kind of taken into account, and then they approve you to be a lead observer and be able to do this on your own, or you have to do it with supervision again.
You can open all the.
Just to clarify, the crossing success identified by NAACC and observers go out to predetermined crossings and verify if it is or isn't crossing, and then data collection follows using the correct assessment, which in our case, like I said above, is the aquatic connectivity non-tidal assessment. We both had to do the process prior to being able to do the NAACC and culvert assessments.
So I'm going to go through what that NAACC assessment looks like. I definitely don't have this memorized. I have the sheet right in front of me, and I'm just going to sort of talk through what we do when we get to a crossing. So that first section, the crossing data, it's all pretty straightforward stuff. You get to the crossing, you get out of the truck, you just start filling it out. Date, town, county, road, GPS, the type of crossing it is, whether it's a bridge, culvert, multiple culvert. Got to take photos of everyone. NAACC wants to know the flow condition when you checked it, whether it's low flow, typical flow, no flow at all. Tidal site, we always click no because, like Brandon just said, we do the non-tidal assessment. Flow aligned, that's like if the stream that's running into the culvert is in line with the culvert, or if it comes in at a sharp angle. Road fill height, bank fill width, constriction, tailwater scour pool, that's like on the outlet side of the crossing. And once that gets filled out, every crossing gets that same thing filled out, and then we go to the structure and ask for different measurements. So we have a big measuring rod, and we got to go in there and measure the outlet shape, measure the outlet grade, inlet outlet dimensions, width, height, and we measure the depth of water and then water to the top of the bottom of the culvert. And we do that same thing for the inlet. And then there's a bunch of other questions that you just answer as you go, pretty much. Substrate type, structure, substrate coverage, physical barriers, severity. And it's important to note that NAACC is looking at aquatic passage only. It's an assessment that looks at aquatic passage only. So the only thing on this NAACC assessment sheet that even looks at culverts or crossings is a question that says crossing condition, okay, poor, new, or unknown. And that's because NAACC gave us a second assessment that isn't quite part of the NAACC process yet, but they still want us to do it. And that is the culvert assessment that looks at specifically the condition of the culvert and not the aquatic passage of the culvert. So this is an example of aquatic passage. So for the NAACC assessment, this picture on the left here is obviously quality aquatic passage. There's no barriers. Aquatic organisms can slide through there pretty easily. The one on the right could potentially be controversial. That's obviously probably a trout hole right there. And you can see there's a little free falling water. And NAACC wants to know that information because if that's too big, trout obviously can't get up it. Depending on the time of year and the water level, they can or cannot get up it. And this looks like it might be slightly low flow in this picture. So in the springtime, I'm sure trout can get up there, but That's just an example of the stuff they're looking at. Here's one we come across a lot is bridge adequate. A lot of the bridges in Cortland County are really nice. The main thing I wanted to point out here is that picture on the left again has two cells, two structures. So on that NAACC assessment sheet that I was going through a couple slides ago, right below the crossing data, structure 1, fill it out. Go on the back of the page, structure 2. As you can see, that bridge has two structures. Each needs measurements and data for it. And it goes up to 3 structures on the page. This is my last one. So once we get all the data from doing those NAACC assessments on aquatic passage, we put it in the NAACC database. NAACC pumps us out these scorings, these scores, aquatic passability score, AOP. And it's in a range of insignificant to severe barrier and everything in between. And to make it easier for us to help towns and municipalities address what they're trying to address with these crossings, we give it our own ranking. The SWCD rank just helps us organize what we get back from NAACC on the crossings that have barriers, moderate barriers, insignificant barriers, or severe barriers. And that map just shows severe barriers is brown, significant barriers white, moderate is purple, minor is blue, insignificant is orange, no barrier is red, and inaccessible is green. And that is something that we did come across a decent amount, more than I expected, was ones that we couldn't get to. Either they didn't exist or there was no way for us to access them. And that's just.
Those also account for crossings that were identified by NAACC, but when the observer went to look at the crossing, there was actually not a crossing there because they're using aerial imagery to try and find crossings.
Yeah. And that's an important note is NAACC identified where they thought these crossings were that we went and visited.
So we move now to the culvert assessments. This uses the connectivity data with some added parameters for conditions of the actual structure that is the crossing, whether it be a box culvert or a metal round culvert or swash pipe. But these are the parameters that are asked in the data sheet, which is right here. And then the categories for each of those measurements are adequate, poor, critical, unknown, or NA not applicable. Some don't have head walls and wing walls, which one of the questions is asking about, or they don't have footings, and so on. But longitudinal alignment, if the pipe is actually flat or going the correct direction, not pitching up or pitching down, going against flow. Channel alignment, if it's with the channel. Level of blockage, there could be beaver dam, or we'll see in a later picture, it was just filled up and there was no water going to be able to get through it. Buoyancy or crushing and invert deterioration are different in the fact that the invert deterioration would be crushing or like closing on the end of the pipe, but the pipe's still open on the inside. And then buoyancy or crushing is if the pipe is actually above the water and the water is kind of just floating underneath it and going, not even really going through the pipe. Structural integrity of the barrel is if it's a metal culvert and it has a bunch of holes in it, obviously that's poor or critical. If the joints and seams line up or they're crushing in that section and you can see the seams, they have a whole manual on, it's 25 pages on how to actually assess these culverts. And after we go through these, we'll then create our own ranking based on how many poor, criticals, or adequates they have. And then it's based on this chart below. So it's obviously, this makes it easier for us to try and compile the data and give it a ranking. So then we can later on go and plot it on a map. And then also you'll see later on when we do our summary how we combine them. So this is one of those critical blockages. There's the head wall at the top. Obviously, that's a poor head wall because you can see concrete has been chipped off. You can't tell from this picture, but in this you can see rebar. So that's one of the criteria for calling it poor. But the blockage is critical because obviously you can't even see the pipe, and we couldn't even find the outlet of the pipe. So it's just showing critical blockage. So this is another, this is poor head wall and invert deterioration. As you can see in the top, you can see rebar showing, and this is really chipped off and weathered. I mean, it's going to happen over time, but when were these things put in is definitely a huge factor. And then invert deterioration, you can see this is dry because there's holes in the center of the pipe and it has rotted away, and it's actually just running through those holes and not even making it to the end of the pipe.
And if you think, hold on, go back to that one more. If you think about NAACC, this same culvert is getting a NAACC assessment. You can see there's a big free fall there. So that could be a big aquatic passage issue. Just what we have to think about when we're out there.
So this is the map for our culvert condition scores after we rank them. Obviously, they're ranked in critical, more critical, poor to critical, poor not critical, poor and adequate. And then the reds are the adequate or inaccessible or no crossing condition score, which there was either no crossing identified, but it was identified by NAACC, and you still have to go out and confirm that that culvert exists or doesn't exist. And obviously just see each town is separated, so you can kind of tell which ones have more or less critical culvert conditions. But it's good because here we see that the yellow is the critical condition, and we only have, as you can see, and a lot of them are stacked on top of each other because this map is zoomed out, and there's a lot of culverts that are close together, but there's a lot in there. And there's only 2 that are showing to be in critical condition.
And another thing I wanted to mention is for the NAACC assessments and rankings, we found that there seemed to be a lot more severe barriers to aquatic passage via the NAACC assessments than there were critical culverts. And that's just something to note. Like the culvert doesn't have to be terrible for the aquatic passage to be terrible. And that's definitely something that we found.
And there's a lot of blue, light blue, which is an adequate condition, which, you know, is kind of a testament to the area because they've kept up on their infrastructure, which is great. Now then, and it's also excluding the passability score, which can be visited at a later date if they need to change it.
All right. This is what we were talking about in the beginning, how we combine the 2 scores. So mentioned earlier, we input the data into the NAACC database. They give us back an aquatic passage score, AOP score, and then we give it a ranking of our own just to make it easier to work with the numbers. Brandon just explained the culvert rankings. We then add the 2 rankings together to get a priority ranking of high, medium, low, or non-priority. And this is the data that we got when we did that. So out of all the culverts we checked, there was only 4 high priority crossings when you combine the NAACC assessment and the culvert assessment, which I think is good. That's something that we can more easily pin down and fix quickly if that number is lower, rather than 198 high priorities would not be so good. Yeah. And this is a map of that, the NAACC assessments and the culverts assessments ranking added together. And there's only, like I said, 4, and they're in 2 or 3 towns. So that'll be easy enough to get with the towns and make sure they have the information they need to address that. These are more examples of culverts that have adequate CAF assessments and adequate NAACC assessments both. That obviously happens a lot. That one on the right is very nice. Culverts looking good. Aquatic passages looking good. Let's see.
So how do we use this information? Using maps and data that we collected, we can then collaborate with local municipalities and identify priority crossings. Um, we can bring this to their attention, and have a lot of them probably know that these crossings need to be replaced, and it kind of just reminds them. And there's also a chance that we can help them find funding to replace the infrastructure and do it in an ecologically beneficial way, which will obviously improve connectivity. These are just some of the examples of funding sources for the crossing improvements. Um, National Fish and Wildlife Foundation has Sustain Our Great Lakes, and New York State DEC, obviously WQIP grants, USC, and SWCD Part B funding. Um, so now we can share this data with each town. We can print them a specific map of their town and with where these culverts are. This map will just give them an idea of where the culvert is, but we can go back through from the data that we collected from NAACC and the data we collected from the CAF score, and they're both connected by an ID, whether it be a local ID or a crossing ID that NAACC assigns them. And we can give them the measurements and exact locations of these crossings. So, I mean, in the end, how does this impact our watershed? Um, it it helps improve habitat for aquatic organisms such as brook trout and brown trout found in our watershed. We can use this opportunity to improve water quality by planting trees and vegetating sites that have been improved. Um, Connectivity for aquatic and terrestrial organisms. When pipes are brought back up to new standards, there is a part of it that has to be help with terrestrial passage in the pipe, even if there is water in the pipe. And we can help with stormwater capacities because sites needing work will be brought up to newer standards than when they were originally put in, which who knows when the last time they were put in. And obviously, there's a lot of benefits that could help with the watershed. And these are just some pictures of the sites when we visited. There's these scour pools have a ton of trout in them, and unfortunately, the scour pool, they're stuck in there. So if we can improve it, they can, go up or downstream as they please. And this is a brown trout that we had actually caught by hand and relocated. Then there's
brown trout.
So we'd like to thank you guys for your time and take any questions.
Yeah.
Thank you both. If there's any questions, if you want to put them in the chat, or you can come off mute.
Oh, come on. We didn't do that good explaining.
It's a fairly straightforward process, and it's easy to understand why towns, municipalities, and NAACC itself would want to know that information just to help aquatic life and make sure infrastructure is doing what it's supposed to be doing.
Good morning. This is Frank Rogers at the Capen Institute in West Virginia. Can you hear me?
Yeah.
I can, yes.
Did you get any buy-in from the municipalities? Do you believe perhaps they're looking at this as actionable intelligence?
Yeah, because Russ's information that he told us the other day.
Yeah. So we actually, this was presentation was just on the Upper Tioughnioga Watershed. We've done this through a couple other smaller sub watersheds, and townships have been doing culvert projects, and we've helped them design and get materials and stuff. And they've actually, they've helped with obviously the labor portion of it.
Thank you very much for that. Do the townships manage their own DOH? Or is it a state agency responsible for this, or kind of a mixture of public-private?
Depends on the road, right?
It depends on the road, but most of it is the townships.
Thank you very much for the presentation.
Yeah, thank you.
You're
Frank.
welcome. Thanks for joining us.
You do have one more question in the chat. I don't know if you guys can see that.
Ooh, I just got to scroll down.
Definitely have before.
Yeah, I believe that. So, I believe they have, yes.
Utilize WQIP
QIP
funds,
funds.
that's the question.
Implementation, planning, and replacing the crossing.
Yeah.
Well, thank you both. It was a great presentation. I do want to remind everybody it will be posted on the USC website along with all of the other sessions from 2024 and previous years.
Excellent. Thank you, everybody. Thank you, Emily. Thank you, USC.
Appreciate it. Thank you very much.
Thank you.
Have a great day.